Hello, my name is Tyson Thornton, and welcome to my presentation on a solution to parking, which is based on research and a report created by a group of students at BYU Idaho, which included myself, Porter McGarry, and Kyle Josephson. Millions of people every day park a car. For some, it can be quite an adventure. It can involve a lot of wasted time and money. It can also involve a lot of frustration. The intent of the research and the report was to provide some possible solutions to this problem of parking. Solutions that could decrease parking lot accidents, relieve stress, decrease time looking for a parking spot, and decrease parking lot traffic. We developed a work plan on how we were going to approach a possible solution. We wanted to organize the work and create steps in order to complete it efficiently. We built a calendar of certain milestones we needed to achieve and assigned out responsibilities to the team. Several times a week, we met as a group to work together, talk about our progress, and make sure we were still on schedule. We then developed a proposal so that our team could take on the responsibility of doing the research and making a recommendation for a possible solution to the parking problem. We also emphasized urgency. The problem was a relevant one and it could be resolved through technology, but it would require taking action now to develop the right solution. We talked about different topics to research and ended up with three: a mobile application, a web solution, and an automated parking solution. We assigned one of those solution topics to each member and then created a list of questions that we wanted to research and answer for each topic. We developed questions that had to do with equipment, cost, usability, and scalability. We initially had planned on using a number of different resources for research, including the library, discussion boards, blogs, surveys, and internet articles. In the interest of time, we ended up only using the internet for our sources. Next, we're going to look at the results that we found in the research for each solution topic. What we found after researching a mobile application solution was the following. The most cost-effective computer for development would be the MacBook Pro with an Intel i7 6-core processor, which is priced at $2,599. This was chosen because of its portability, cost effectiveness, and it meets the minimal requirements for this type of project. A phone that runs on Android and iOS, a phone that runs on iOS would also be necessary in development for testing purposes. Currently, the best choices would be the LG Stylo 5, which is priced at $299, and the iPhone XR, which is priced at $599 for iOS. The timeline to build an application is estimated at 14 weeks, and it includes phases for planning, analysis, implementation, and testing. The costs of developing a mobile application were estimated between $150,000 and $160,000. This includes salary for one lead developer, 2 or more supporting developers, and a UI designer or developer. The total in labor cost is estimated at $80,000. Another part of the cost is patent that will need to be submitted. That process begins with a $199 processing fee. will more likely be recurring costs. Once the product is live, then a server will need to be used, and an estimated cost for that is $90 a month. There also need to be 1 or 2 employees working on call for maintenance and support after the go live, and that's estimated at $14,400 a year for the salary. The projection is that this solution could be marketed and sold to customers worldwide, which consists of over 3.5 billion cell phone users. The investment could be returned between 2 to 3 years and a profit yielded after that. The second topic research was a web solution. There were 3 different possible web solutions that were researched: a GPS satellite view, live video streaming, and a custom-built web app. While researching a solution involving GPS imagery, we found that the technology exists, but real-time satellite images are not available for commercial or public use at this time. Google Maps and Google Earth provided an image of a GPS coordinate, but the image is not up to date. Those images are updated monthly or sometimes only just every few years. A web solution using GPS images was found not to be a viable option right now. The second web solution was streaming video live to a website from an external webcam, which would show real-time video of the parking lot and what available spaces are there. At least one webcam would need to be purchased depending on the lot size, and there's a wide range in costs, ranging from $35 up to thousands of dollars. There would need to be some setup to install the webcams and connect them to the internet. The average estimated labor cost for that service is about $384. The business would also need to have at least one computer connected to the internet, which would cost probably $170 to $4,000 for a computer, and then about $50 to $300 monthly for internet service. The video could be streamed directly to the business's social media page on Facebook, YouTube, Instagram, or Vimeo. There are restrictions for all platforms, but it is a free option. The client could also stream the video to their website. This would require them to have a website and a web developer to add the live stream video to a new web page or an existing web page. And that has an estimated cost of about $400 for 2 to 4 hours of work. Altogether, this solution has an estimated total of $760 on the low end and $23,000 on the high end. The estimated timeline is 7 to 23 weeks to complete and includes milestones of equipment purchasing, equipment installation, and website or web page creation. The third solution researched was building a web application. This provides a lot of freedom to the client to design something specifically for their needs. This could be an application that is designed for general use and then marketed to different businesses, or it could be customized per client. A software programmer and a web developer would need to be employed. The timeline for the solution would be 4 months and includes milestones of planning, programming, testing, and product launch. The total estimated cost starts at about $67,500. The last solution that we researched was for an automated parking solution. This is a solution already being used today and involves movable storing options, much like a vending machine. It efficiently uses space by stacking or using movable platforms. The solution also provides a quick and convenient solution to the customer because it takes an average of 75 seconds to retrieve a car from an automated parking garage. We researched 3 types of parking to compare, and they are Carvana, CityLift, and just a concrete garage. Carvana builds parking towers that hold 26 to 32 cars and is fully automated. The estimated cost to build a parking tower is $5 million. CityLift builds a custom garage with full automation, and that's estimated between $11,000 to $14,000 per parking space. These custom garages can hold 8 to 21 cars per level and can be up to 7 levels tall. The third parking type was a concrete garage, costs about $20,000 per parking space to build, and for a structure of about 5 levels, the total estimated cost would be about $8.5 million. One major drawback to the solution is upkeep. With an automated system, it could lead to more repair and maintenance costs. Considering the research, our team agreed that there are two clear solutions that we would recommend moving forward with to a potential client. Those are the mobile application and the web-based live video streaming solution. The mobile application was chosen because of its freedom in design and development and reasonable costs. The video streaming web app was chosen because of its potential in a quick launch and low cost.